equal to, we're in the final stages, guys. 2d over c, 1 minus v squared over c squared. I guess I have to square root that one. Sad. 1 minus v squared over c squared. Wait a second. 2d over c. That seems kind of familiar. Can I find that somewhere before? T naught. And that, folks, is the equation for time dilation. Awkward. London deca, Paris deca, or deca Japan. Michael deca, Elvis deca, so deca Meridian. Sarah Zogne, Kahi Nagi, relativity. Hello everybody, my name is Professor Simona Barry from Barry Science Lab, where relativity is more beautiful than Michael, Elvis, Paris, London, and Japan. Although the high-speed trains are pretty cool. Alright, so, now let us salute Einstein for laying the foundation of modern physics. Thank you. Guys? I think I sent him to New Jersey one too many times. Yeah, we're just gonna ignore that. Oh! He stopped crying. Never mind. Well, bye. You may have noticed that it took me, longer than usual to, put him away. Let's just say that one. So, why would that happen? That's right. That's because of time dilation. Alright, so what is time dilation? Well, time just dilated a lot there. So if you can see it, you just heard what time dilation is. Thank you everybody for watching, and I'll see you next time. Idiots. They didn't know that, I'm not calling you guys an idiot. That's not my ego. You see this compass? That's how big my ego is. But, people probably thought, hey, maybe the video's over. That was a pretty short thing. Oh, I guess I now understand time dilation. And this was a scam. Dislike. But wait, for those of you who looked at the time bar, report to everyone else that the video's not yet over, please. Alright, so time dilation. What is time dilation? Well, first, I don't want boring text. And when I say boring text, I mean boring text following me all day. So, I'm going to turn off the text, and I'm also going to say bye-bye to these guys. And by home, I mean a gigantic ball that's absolutely huge and is twice the size of some rogue planets. Even some dwarf stars out there are bigger than this. So yeah, I hope that gave you a non-existential crisis, or like an anti-existential crisis, or an ego crisis, I guess. So let's say you have an Earth dude, and suddenly he sees this guy traveling at, let's say 1/2 the speed of light in a rocket, a glass rocket. So everybody can see what's happening in there. Better not change clothes, if you know what I mean. Alright, so, we'll just ignore what I just said there, move on. So what the space guy does is, the space guy, that's too small of a space dude. The space guy, he has brown hair, and what he's doing right now is he's pressing a button, and that button turns on a laser. What is this supposed laser? Well, this laser is right over here. And as soon as he turns it on, it hits the mirror that's on the other wall and then bounces back. So, if we call the width of the rocket, well, d, which is a very generic name, the time, well, the distance it travels was 2d. So, since t is d over v, classic, that means 2d over c is the speed of light for this man. Or, well, I mean the time for this man. But what about the Earth, sir? Earth people, Earthlings. What did the Earthlings see? Well, if we copy this situation over and over again, maybe we can get an idea of how this looked like. Alright, so thank goodness it's actually the same size. No, not that. I don't want that. I don't want it. And I guess that's right. What the Earthling sees, I'm not gonna lie, the space guy looks like a chimp, is the Earthling sees it start. Well, I'll record down what the Earthling sees of the laser in green. But then, the thing, well, this spaceship travels length L, which we'll call velocity of the spaceship times the change in time between these like iterations. And then you have to go all the way back down to the light source. And now what it sees is, well, it sees that the laser has to make 2 trips, but the 2 trips aren't the same. God damn, I tripped again. Trip counter 11. Alright. So, the thing is, oh sorry, not the thing is, that's just a buffer. A buffer. Alright. So, now T is 2D over C, but that's only for the spaceship dude, chip guy. So, we'll put T naught on it, because he sees naught of what the Earthling is seeing. And the height of this thing is, well, D, but the length of this is L. So, well, if we make like this diagram, then we can say that this is actually D and this is actually L. So, this trip is a little different than the other trips because, well, distance formula. And you have to multiply that by 2 because of, well, the other side. The greener side, if you know what I mean. Go check out Plague Bricks. Totally not sponsored. Alright. So, now, this trip, well, T is D over V. This time, no not. No not. Instead, D squared plus L squared over C. A difference in time? How could this be? Alright. So, well, let's just see. See. What happens when we just revert this to its original form? C is equal to, well, let's do this. D squared plus L squared over D. For time dilation. Just kidding, no.
People gonna have heart attack that way you talk.
And this is gonna be equal to, alright, I forgot. Not working. The noggin has to work. The noggin has to log in. So, somebody's logging my noggin. Well, let me just make this simple. By the way, this is actually V delta T over 2. Sorry. Noggin has some logging to do. logging into the account. V squared delta T squared over square 2 squared. Oh no, 4. T. Alright. So, now, to get rid of this mess, we're going to square both sides. Giving us C squared is, well, well, did I forget something? I did not. Thankfully, C squared is equal to D squared plus V squared, delta T squared over 4 over T squared. T squared. And now, what's happening over here? Well, here we have an abomination that is not to be touched. Oh, damn it. Did I forget a 4? You're kidding me. I forgot a 4. Well. Look at me now. I somehow forgot that I had to multiply this by 2. So, in the end, there's actually a 4 covering this since you have to square the 2. Alright, Dumbo me. Giving us 4D squared plus V squared delta T squared over T squared. Jesus Christ. Oh, we get C squared minus V squared if we subtract from both sides 4D squared minus over T squared. And now, what we do is we cross multiply. C squared minus V squared over 1 equals 4D squared over T squared. Cross multiply. It's kind of fun. And we get T squared times C squared minus V squared equals 4D squared. A lot of squares over here. That gives us T squared equals 4D squared over C squared minus V squared. And we square root everything. Get T squared is equal to 2. Well, first let's factor out C. And what we get is T squared equals 4D squared over C squared minus V squared equal to C squared times 1 minus V squared over C squared gives us T is equal to, we're in the final stages, guys, 2D over C, 1 minus V squared over C squared. I guess I have to square root that one. Sad. 1 minus V squared over C squared. Wait a second. 2D over C. That seems kind of familiar. Can I find that somewhere before? T naught. And that, folks, is the equation for time dilation.